is geometry.
Notes.
Yes. I will always recommend that you follow along. Yes, take the notes because you can use them on quizzes. You can use them to reference anytime. Geometry. And this is the beginning of Unit 1. Okay. And what is in this unit that we're going to kind of title it is measurements, angles, and constructions. This as well. This is our day 2 notes. And it is Tuesday, January, what is it, the 14th today?
Yes,
Yeah,
ma'am.
perfect, January 14th. Awesome. Okay. So, there's a few things that I handed you guys before we got started today. First of all, the handouts. I'm just going to flash these on the screen. So if you're watching at home, this is for you guys here. This is in case anyone's watching at home. If you're watching at home, you need to come and get these from your folder. They're going to be helpful. There's a construction guide, and then there is a paper that says the giant inch. We're going to talk about those today. So, something else I passed out to you all are these two things. I told you what they were called, but just like for a second. Does anybody remember? Let's start with this one.
Protractor.
Protractor. Okay. So, a protractor is a tool that we use. We can use it for lots of things. You see, we have some measurements on the bottom. These measurements are in inches. And then around the edge of a protractor, you're going to see two sets of numbers. One set of numbers is going to start from 0 on the right side, on the inside, going 10, 20, 30, 40, all the way up to 180. It's not written, but 180 is the missing number after 170. And then the other set of numbers is on the outside, where it starts over here from the left, from 0, 10, 20, 30, 40, 50, 60, 70, all the way up to 180. Okay. So, we have that. This is the other tool that we have that will be used in this class, a ruler. So I'm kind of just showing you things right now. If you do not have a ruler in front of you, check the rectangle bins on your table. If there's not one in one of those bins, let me know. I'll make sure that you do have one. But this is a ruler. Okay? Our ruler has 2 different units of measurements on it, labeled on the ruler as well. The side with the spaces that are further apart, numbers are further away from each other, that's going to be our inches. And if you flip it around, you're going to see numbers closer together and a little tiny cm for centimeters. Okay, I'm not asking you to memorize those units. You don't need to write them down. Just want you to be aware of them. So if I tell you to measure something in inches, you use the big ones. Centimeters are the little ones. So let's talk about the different things that we use all of these tools for. First of all, let's start with the ruler. Okay. What can you measure with a ruler? Any ideas?
Anything and
Water
everything.
bottle.
Yeah.
Pretty much anything.
Everything, pretty much.
Everything, as
Yeah.
long as it is as long as the ruler or smaller.
Yeah.
Now I guess you could stack a bunch of rulers on top of each other
Yeah.
and measure something really long.
Yeah.
But you have to be careful because with rulers there is a way to be accurate that most people don't know. So I want to talk about that with y'all today. We're going to zoom in really close.
Oh boy.
Yeah. And
Shucks.
okay.
That's extra close.
So if you want an even closer look, the paper I passed out that says the giant inch, that is just a zoomed in version of the ruler between 0 and 1. That's all that is. So whenever we do use a ruler to measure something, let me ask you, where would I start measuring? And to ask you, let me draw a line first. I'm actually going to have everybody do this. Put your ruler up against your page somewhere and create a line. It doesn't have to be exactly the same length as mine, but I'm going to say let's make it about somewhere between 3 and 4 inches. So here's my line. If I wanted to get an accurate measurement of this line, would I put my ruler like this?
No.
Nope.
Right
Why?
on the long line.
Zero.
Extra.
Yeah, so what a lot of people don't know about rulers is this big line right where the 0 is, that's your starting point. A lot of people will line up the edge, but if you do that, your answer is going to be off by about a 1/16 of an inch. Now, unless you're doing something like construction, or trying to build something, then it might be okay to still measure it from the edge. But for the purpose of being accurate, the starting point is here. You see that?
Mm-hmm.
That extra space is going to give you an incorrect measurement. So when we measure things, we start there. That's our starting point. And does anybody know what all these little tick marks in between the inches are?
67 inch and 1/8 inch.
Yeah. So we have 1/16 of an inch. We have 1/8 of an inch. We have 1/4 of an inch. We have 1/2 inches. All these little marks mean those different fractions. And here's what's happening when we do that. When I have an inch, I'm going to zoom back out and show you my big inch. Okay. Just by looking at this, could any of you tell me why we're doing 1/16, 1/8, 1/4, halves? What's the reason for the numbers that are being put there?
There's 16 notches in it.
Yes, it's like there are 16 little notches or sections inside of this inch. It's just being divided into 16 parts. So if I go here, this little notch, we have 1/16 of the inch. If I put 16 of those besides each other, I would have 1 inch. Now, whenever we get to here, the second notch, this would be 2/16 of an inch,
Which would be 1/8.
which would be 1/8. It's just the simplified fraction. Then we get 3/16. Then we get 4/16, which is also 2/8, which is also 1/4. Beautiful. And it just goes on for the rest of the ruler. Now, if you are working in construction or some field where you need to have accurate measurements often, this is something you will have memorized. Any construction worker or person that uses power equipment that I've met, it's like they have this down pat. It's like their second language. I don't believe in memorization. Realistically, I don't think you're going to be measuring things in 1/16 of inches every single day. So that's why I gave you this little cheat sheet. We can reference it, but I do want to make sure that we understand how to read it. So let's look at the lines we drew. And remember, our lines are going to be different. But let's just make sure we understand how to measure accurately. So first of all, we don't want to line up with the edge of the ruler. We're going to line up with that very first notch right before the 0. And then we want it to be touching really nicely along the whole ruler. So looking at my line or yours on your paper, let's see. I know it's more than 1 inch, more than 2 inches, more than 3 inches. Is it more than 4 inches?
No.
No, we're just at 3. So what I like to do is I like to mark where the nearest whole inch is. So I give myself kind of a stopping point to count from.
3 and 7 16.
Is that what mine is? I didn't even count it yet. Let's see.
I don't know. I can barely see.
I know, it's tough to see it from where you are. Now that I'm here, let's zoom it in a little. And then I'm going to have to move my paper. Oh no. Okay, so here's where mine is. Yours might be different. Just keep that in mind. But if we're looking at mine specifically, oh my goodness.
Oh boy.
Come on now.
Oh, Lord, I feel like I'm gonna die.
Okay. Oh, Lord, have mercy. My glasses don't even work for that.
Okay, there we go. So let's start looking at how many tick marks there are after our nearest inch.
Okay.
So I have 1, 2, 3, 4, 5, 6, 7. See that? It lines up pretty good with that 7 tick mark. So I'm going to take that number in my brain. I'm going to take 7 in my head. And I'm going to reference my giant inch paper. I'm going to start from 0 and I'm going to count 7 tick marks and see what fraction I land on. You guys tell me, what fraction did that give you?
16.
7/16. So the measurement of the line I drew would be 3 7/16 inches. Not too bad, right?
So,
You got 8 on yours,
yeah.
and that is totally fine. I bet all of ours are a little different, and that's no big deal. So let's say you had 8 extra tick marks. What would your fraction be then?
A half and a half.
Yeah, exactly. You would have 3.5 inches. So very close. Your answers will be different, or unless, I don't know, maybe you got lucky and it's exactly the same. But that's all we're going to do. Now, in terms of how we're going to use this skill in this class, on the first quiz you take, the first question will be measure the line to the nearest 16th of an inch. That's the only time we're going to do it. Okay, just full disclosure, that's it. So, does everyone in this room feel like they could successfully do that, or would we like to run through another example? I'm happy to run through more if we need
Can
to.
we run through one more?
Let's do one more.
Yeah, we should.
All right, one more just in case. This time, I'm going to draw a line. I don't know, I'm not even going to look at the numbers, I'm just going to draw it. Okay. And I'm going to say that is my stopping point. Let's see, I'm about to tell you. So, my starting point before 0.
67 16.
Oh, yeah, that's so quick. So, it's going to be a little bigger than 6, but not quite 6.5. And Mac, you were able to recognize that crazy quick. That's awesome. So, if 6 is the nearest inch, I'm going to make my little mark here on about 6. And then I'm going to count how many tick marks come after it. 1, 2, 3, 4, 5, 6, 7 again. Oh my gosh. Well, we just got lucky, I guess. So 7 tick marks. We're going to count 7 spaces on our giant inch. And what fraction did that give us again?
3 and 7/16.
7/16. I should give you a different one. Sorry, guys. This one would be 6 7/16 of an inch. Okay, one more for good measure. I'll do a different one. Let's do like a really tiny one. Okay. Can I zoom in, or does anybody need to see this? I'm gonna zoom in. And then I'm gonna focus it. So I had a really tiny one now. And I'm gonna start it right here. Let's see. Now you could count from 0, however many that is, or you could say, well, 1 is here. You could count backwards so that you're counting less. It would be 1, 2, about 3 spaces.
13/16 of an inch.
1, yeah, 13/16. Absolutely. If we did it the other way, it would be like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Am I right? Or is it up to 14? It's kind of in between, isn't it? I'm going to say right there. We got to the 14th one, right?
That's 7/8.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
I don't know, little lines
12,
confuse me, I
14.
don't know.
I know. Now, it's tricky when it's kind of in between measurements. Again, I'm going to ask you to do it once. If you're off by like a 16th, I'm not going to count it wrong. I just want to make sure you're in the ballpark. Okay. So this wouldn't be quite an inch. It would be, depending on where it fell on your paper, about 13/16 of an inch or about 7/8 of an inch. Something along those lines. Okay. Zoom out again. Just have that giant inch paper handy, and I think that will help you. So I'm gonna write 13/16 of an inch, and that's how we abbreviate inches, just IN period. Do you have any questions about using the ruler for inches? All right.
I don't have a question about that,
Mhm.
but, like with the foot and all that, you know, how you have the tick mark.
Yes.
with- if you don't use the IN, if you use the 2 tick marks for inches, is that
Ooh,
acceptable?
Okay, so let me repeat your question in case someone didn't understand. Star wanted to know, instead of writing IN, could you write, this is another way to write inches, could you write these 2 little dashes? What would this be called?
They're a tick mark.
Quote mark, tick marks? Yeah, this is actually another way to label inches. You can do this too if you want. You're the first person that's brought that up to me. So yes,
I'm a
you
construction
can do
guy.
that. Ah, well, there you go. So yes, you can either write inches or you can write the 2
Tick marks.
apostrophes, tick marks. Yes.
Because the 1 tick marks, is for like feet.
Yes.
the foot.
So you just read my mind. I was
Yeah.
about to ask, can you do it with 1?
No,
No, because that means feet.
yeah,
Yes. So these are both acceptable ways, either inches or the 2 tick marks like that. Okay. So there's our quick run overview of a ruler and how to use it. And we were talking about lines and stuff. But let's get technical about how we speak about lines and other things in geometry. Because I actually spoke incorrectly. These are not lines.
They're like segments.
Yes, you already know it. Line segments. So let's start writing a few definitions. The first definition, the first word we're going to talk about is just a plain old line. So line. 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 Does anybody know what a line is?
The line. It continues in all both directions.
Yes. So a line is
Perpendicular or parallel.
Yes, yes. A line is basically difficult to describe. It is a straight point, straight angle. It's a straight line. A line is a straight line.
A line is a line.
Yeah. A line is a straight marking that goes on in two opposite directions forever.
Infinity.
For infinity. So a line, I think a picture would be better than words.
Yeah.
It looks like this. These arrows tell me that they go on forever in opposite directions. Perfect.
I really can't stand these clocks in these classrooms.
Yeah, why not?
Gosh, I've never been the type to like to look at the time like this. So look up there, I see the clock right there. Like I used to work in factories.
Oh,
And
yeah.
they had clocks everywhere. Like I'm just anytime I get a chance to just look around for 1 second and I see the freaking clocks and I'm like, no, yeah, that's
Does
just
it stress you
yeah,
out?
yeah. I don't
Hate
yeah,
that.
yes, with the ooh Lord, embassy. It's all right.
I used to be like that when I was in school and I was a
Girl.
student. I'd be
That's
looking at the
horrible.
clock like
Yes.
it's only been 5 minutes.
Yes,
Feel like it's
true.
been 30.
Ridiculous. That's for real.
Okay, so now we're going to talk about what Kelly said. What we normally see and what we can measure. First of all, a line cannot be measured. You cannot measure its length, but you can measure a line segment. So let's write that. Line segment. segment. Line segment. And a line segment does not go on forever. A line segment is essentially a portion of a line. It is a line that has two endpoints. So a segment is a part, a piece, or a portion of a line, and it has to have two endpoints. We have a line, we have a line segment. Now we have something slightly different. I want to see if anybody knows what this is before I write down the name. What about something like this? It has one endpoint, and then the other side goes on forever, never ends. Has anybody ever seen something like this or know what it might be?
Mhm.
I'm going to tell you. This, and it's super easy to remember, so I'm going to give you a trick. This is called a ray, R-A-Y. And here's what helps me remember that it's a ray. I think of it like a ray of sun because the sun's rays start at a point of origin and then they shine on forever and ever and ever. And I'm sure they technically do end at some point, but to us it feels infinite. So the sun, or a point that starts here, there's a point of origin, and then it goes on forever in a certain direction. That's a ray. So this has only one point, and then one end goes on forever. One end point. One end goes on forever. Okay. So we have a line segment, we have a ray. Now we're going to move on to something that's not just going in technically two directions, like lines and segments and rays do. Let's talk about what happens whenever I put two rays together. What if I have, yes, that would be an angle. If I have a point that a ray comes off of, and on that same point, another ray comes off of it, this is what we call an angle.
So cool.
Angle. Here's another word. Does anyone know what this point is called whenever it is on the edge of an angle? It starts with a V. Has anyone ever heard it? Vertex. Yes, it's totally okay if you don't know these words. I'm teaching them to you now. I don't expect y'all to know them. Some of you may have heard it in the past. This is what we call a vertex. Okay. So to describe angle, if you want a definition to go with it, we're going to say two rays that share an endpoint. Now, based off of just what I have shown you and what I've had you write down, could anybody tell me what they think the difference might be between a vertex and an endpoint?
Or two lines. Me?
Yes, the vertex is going to be telling us where those two lines meet. They're going to be forming an angle, and it's going to be typically like the corner of something. That vertex is going to be touching at least two lines here. An endpoint is typically just connected to one line, depending on the context. That's just a question for fun. Okay. Does anybody still need this page? I'm happy to keep
One
it up.
second.
Yes,
Okay,
please.
take your time. Pause it while you finish that up. Okay, so that was, I'm going to label this as page 1. And we're going to start a second page of notes now. This is page 2. Unit 1 still. And this is our day 2 notes continued. Okay. So we have made it up to the point where we fully know what an angle is. Or at least if I say angle, you can picture it in your head. It's one point, one vertex where two rays are shooting off of it. So let's talk about a few different types of angles. What I would like for you to do at this point is take your protractor and put it on your paper. We're going to use it and we're going to draw some angles together. We're going to construct a few angles. So we are going to talk about 3 different types of angles. The first type of angle is an acute angle. Yes. The next one, and I'm gonna make this take up my whole page. I'll show you what I'm doing. I'm gonna put obtuse probably in here, and I'll write here. Obtuse angle. And last but not least, does anybody know the third type?
Right?
A right angle. Good.
That was the easiest one.
Yes. Cute, obtuse, and right. Let me zoom in a little bit in case we need help with the spelling. There's 3 different types that we will talk about, and we will write out definitions for them. Then we're going to draw pictures. So first of all, does anybody know what we measure angles in? What are the units?
Degree.
Degrees. Good. So degrees, it's kind of the same. I think it is the same spelling as degrees outside, like degrees Fahrenheit, but it's not the same thing. We're not measuring the temperature of the angle. We are measuring the size of the opening. Degrees is a special unit we use for the size of an opening at a certain point. So an acute angle is any angle that measures less than 90 degrees. So let's write that here. Less or smaller than 90 degrees. And the way that we label degrees is a little tiny circle at the top right hand corner, like that. Less than 90 degrees. Next, we have an obtuse angle. More than 90 degrees. Good. More than or greater than 90 degrees. All that's left for the right angle.
90
degrees.
Exactly 90 degrees. It must be exactly. If it's 90.5 degrees, it's obtuse. It has to be exactly 90. So we need to write exactly 90 degrees. Okay. So let's draw some of these. We'll draw a few examples of each type. So back up to the acute angle. Let's bring our things, protractors. I'm always forgetting the name of this tool for some reason. And what we're going to do is we are going to draw some acute angles. And here's how we will do that. First, let's move this over so that the circle at the bottom above the 3 is close to the edge of your paper, because we're going to have this be our starting point, and I'm going to have us draw angles that open to the right side. So here's how we're going to begin this construction. First, I'm going to take my pen and just put a little dot where that hole is. Okay, and then I'm going to go over to the right and draw something to tell me that this is where the other end needs to pass through, right down at where 0 would start. So right there. And what we're going to do is we can use the protractor or we can use a ruler, is I'm going to connect these 2 dots. And I'm gonna make this one just a little bigger. And we're gonna draw an arrow on that side. So once you have that ray drawn at the bottom, we want to put our protractor back where it was. And we want to be really careful about how we line this up. First of all, your vertex should be lined up with that hole in the bottom of the protractor. So let's line that up really nicely. Where the ray begins should line up with this line outside of that hole. And then the other line over on this edge of the protractor should line up with this part of your ray over here. This way you know you have an accurate measurement. And we're going to start counting from 0 all the way up to any number that is less than 90. You can pick 10, 20, 30, 40, 50, 60, 70, 80, all the way up to 89.999999999. As long as it's not 90 degrees and it's less, then you have an acute angle. For this example, what I'm going to do is let's do a 40-degree angle. So, am I looking at the numbers, do you think, on the inside or the outside?
Inside.
Inside. Does anyone want to explain how they were able to tell we're using
Because
inside?
if you go to obtuse, it's going to go to 180.
Mm-hmm.
So you're trying to do it under 90 degrees, so you're going to go.
Right. And also, our angle is opening from here and we're moving up. Does it make more sense to go from 0 to 10 to 20 to 30 or go from 0 to 170, 160?
10.
It makes more sense on the first one. So here's how we make an accurate marking. I'm going to go up to 40 degrees right here. And there are 2 different places that you could make a mark. You could do it right here under that 40. Or you could follow that 40 all the way out here and you could draw it on that edge. Now, I think I'm going to do on the inside just because I don't want my words to get written over. Either one is going to give you the same measurement. But once you give yourself that little dash mark, now you have a guide to connect the dots and make the correct measurement of an angle. So I'm just going to use this as a straight edge. Connect that little dash I made to my vertex. And voila, an angle. And then here's how we label this. Once you have that drawn, I'll show you. To label an angle, we're going to put this little line inside of it. This is called an arc. So if you want to know, arc. A-R-C. And to label it or how big it is, how many degrees it is, we just write directly next to that arc the 40 degrees or however many degrees you made your angle. So I'll write 40 degrees. And that's how we would label it. Okay. So I will leave that up there, but we're going to move on to the obtuse angle. This one is a little bit tricky to draw because we're going to need to start somewhere that's not right on the edge of our paper. Technically, you could start on the edge of your paper, but your second line or your second ray of your angle is going to be really short if you don't give yourself enough room. So I'm going to start mine, I don't know, like right here. And I will give myself a starting point and an end point here. Okay, I'm going to draw a line.
Miss Taylor,
Yes.
Okay, I am guilty. I was just thinking about the brakes on my car. And like honest and about walking down to this bus stop and I was thinking about leaving early. So
Do you need to go?
I didn't see what you did.
That's okay.
I
That's
didn't see
okay.
what it is
No.
that you
Oh my
did.
goodness. I appreciate you saying
Yes.
something.
No,
I
sorry.
don't want you to be confused.
No.
That is
Thank
okay.
you.
Do you mean for the acute angle?
No, that's the obtuse angle.
Okay.
I was my brain.
So I think I actually want to explain this in a slightly different way anyway, because as I was drawing this, I realized what a pointless way to do this. I'm adding extra steps for no reason.
Okay.
Your starting ray, you can just draw a line with a ruler or with a straight edge. There's no reason to start with the connect the dots thing. You can, but you know, what's the difference between me dot dot connect and just drawing a line? It doesn't matter. Just make sure your line is long enough that it does reach past this little open circle at the bottom and it can touch here so that we can see where the starting point is. Okay. So once you have your ray drawn, this is where we have to be careful about figuring out what that angle is going to look like. Because what some students might do is this. Is this the correct way to line up my protractor?
No, it should be on a dot.
Oh, yes, thank you, Mac. You need to make sure that your vertex, that point, goes right where the hole is. Right here. And then you need to make sure that the edge is on the other end. So don't just do something like this. That's wrong. Make sure it's all lined up. You want to be as precise as you can be. Okay?
Did you say turn this stuff back in when you
Yes.
get there?
Yes.
Even if it was in the basket?
You know what? Okay, I made everybody last term turn all that stuff back in, but they would have to get it back out every day. Let's leave the tools I passed out. We can keep them at the
Okay.
desks. That's fine with you. Okay, so if I want to draw an obtuse angle, it needs to be more than 90. Okay, I'm starting from here at 0, going up, going up, going up. How would you describe to me where 90 is on a protractor?
In the middle?
Yeah, right in the
there,
middle,
smack in the
straight up and down. So whenever you have a straight up and down angle, that's a right angle. Obtuse just has to be open bigger than that. So you could just make it a little bigger. You could make it a lot bigger. See how one, okay? See you,
See you
Matt.
later.
I'm gonna make mine 130 degrees. So if I'm opening from the right side, counting up from 0, would I look at the numbers on the inside or the outside?
Inside.
Inside, good. If I'm starting from the right, I need to start with the numbers that get bigger this way. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130 is where I want it. Just make sure I'm lined up good. 130. Okay. And then we just connect the vertex to that little dash we made. Same thing the label, draw an arc, and I'm gonna write 130 degrees. Okay, and then last but not least, your right angle is exactly 90 degrees. So it should look like the corner of most tables, oh my goodness, broke my own rule. Sorry guys, did not have my phone on silent. It's gonna be like the corner of a piece of paper. It's gonna be perfectly up and down and then perfectly left to right. That perfect 90-degree angle. Okay. So I'm gonna start with a straight line.
to make a very quick.
The acute one? This?
So when we start, we could just make the line.
Yes. So I think I showed you guys way too many steps for absolutely no reason at all whenever I was making that first line. When you make your beginning line, you can just draw a line.
Okay.
Yes.
So we always start at the
Yes,
circle.
whenever you're measuring and you're making sure that, it's gonna be long enough so that like if I had one that started here and it was shorter,
Yeah.
when I would go to measure, you would see that it's not reaching far enough to give me an accurate measurement. Now, this is lined paper, so technically I can tell right now this is accurate because it's lining up. But if I were looking at something that didn't have a line that continued, I would need to draw the line longer. Good question. Good question. Okay. So I have my beginning line or my beginning ray. Vertex gets lined up with that hole at the bottom. Make sure that this other line is lined up with your ray here. And we can see 90 on our protractor straight up and down. So make a little dash. Connect the dots. Just like this. Now a right angle is labeled a little bit different. Yes.
Yeah.
Instead of drawing the arc, or like this, it's like part of a circle, you will draw a square inside. This means 90 degrees. See it happen.
See y'all tomorrow.
Or perpendicular.
Yes, or perpendicular. Beautiful. And perpendicular lines do cross at 90 degrees. Beautiful. So if you ever see the square, or if you ever write that square, you don't technically need to label it with the number 90 either. You can just do the square and that's good enough. Because this will only ever mean 90. So you can draw a bunch of different types of acute angles. You can draw a bunch of different types of obtuse angles. Can we do a bunch of different types of right angles?
No.
No, there's only one, and it's only 90 ever. You can have longer arms of the angle. You can have it facing a different way, but that angle measure will never change. Ever, ever, ever. Okay. Does anybody need this paper still? I know I said that we might draw a whole bunch of these, but I'm looking at the time and I want to make sure that y'all have time to do the exit ticket. Okay?
Shame on you.
I know, Shane. Does anyone need this still? I can move forward. Okay. Cool. So I'm gonna go ahead and give you this exit ticket today. If anybody wants to wait until I write it, I can go and make copies of it and bring it back. I'm gonna be making copies anyway for the people that aren't here today. Just whenever I go, I'll ask who wants one and I'll have you raise your hands for me. So this is day 2. Exit ticket. And if you are writing it on your own paper, please write day 2 exit ticket on there. So that when I go to grade it, it's much easier for me to keep things organized and put things in the right place. And again, don't feel like you have to write this. I'll make copies if you want it. So for your exit ticket today, remember that it will be due Friday, January 17th, no later than 12 p.m. noon.
So what's this again?
This is our exit ticket, which is basically the assignments I will give you throughout the week. You're welcome to finish it in class. We still have 20 more minutes. Or you can take it home with you. It'll just be due by Friday. So this will be a simple one today. What I would like for you to do is draw and label the following angles. And I'm just going to give you a few measures in degrees, and you're going to construct them with your protractor. Use a protractor. Okay, number one, I want you to draw an angle that is exactly 45 degrees. Number two, let's do an angle that is 90 degrees. And then number three of them, that'll be it. I want you to draw an angle that measures 170 degrees. Okay, so when you draw them, remember what I'm looking for is that you write how many degrees, you make sure you put the arc in there. And I also would love for you to tell me, is it acute, is it right, or is it obtuse? I will write that as well.
Shame on you.
Right, I know, I'm so mean. Right, or obtuse. Okay, so I am gonna go and make copies of this. Would anybody like a copy of this? If you would like one, raise your hand for me. If not, I'm not offended. I'm just gonna go make copies for the people that are not here.
Well, we can always do this tomorrow when we get here, right?
Yes, absolutely.
All right. I gotta go now.
All right.
All right.
Well, I will see you tomorrow.
Yes. See you tomorrow.
And that is all for today. So if you have things that you need to do, you need to leave, no big deal. This will just be due by Friday.